Hello, welcome. We're going to do our relatively short video today on tornadoes and a quick case study and jump into precipitation next week. So again, the idea is that you should definitely view this and take some notes well prior to the final exam, but as already alluded to, this is not on the next exam if you choose to watch this on Friday, Saturday, or Sunday. Again, rating tornadoes, the idea that we can't simply look at a tornado out in the field and be able to say, that's an EF3 tornado. We are going to have to do a post-mortem analysis after a tornado has occurred to be able to tell, technically speaking, how strong it was. And so again, the idea that we're going to do surveys, we're going to have National Weather Service meteorologists head out to the field to figure out exactly how intense a tornado was. And this is still far from an exact science. We may have it hit an area with dilapidated barns, or we may have it hit some well-structured buildings in a suburban area, or we may have it out in the middle of a cornfield. And so we do our best with our understanding of how tornadoes and certain wind speeds do damage to certain objects, and we try to give it a rating after the fact. And so this is somewhat where we ended off on Wednesday. The idea of the majority of tornadoes are weak, and these are going to be the ones that cause very few injuries and very few fatalities. The ones that we're concerned about are technically the EF2s and up, which we're going to call significant tornadoes. EF3, you can start to see we're damaging interior walls, and then the violent tornadoes. The top 1% are going to be the ones that cause the majority of fatalities. Again, these are very uncommon. We do find them in areas such as northwest Indiana on occasion. You may recall early in the semester I brought up an event in Plainfield, Illinois. You likely don't, because it was very early in the semester and everything was kind of in disarray as we were getting started. But this would have been still the only EF5 tornado at the time, an F5. This is the enhanced Fujita scale, as you can see on the screen. The only EF5 that ever occur in the country in the month of August, and that's still the case. So you can see the wind speeds associated. EF0 tornadoes can have winds as low as 65 miles an hour. And when we get up to EF5 strength, we're talking about winds in excess of 200 miles an hour. We have had direct measurements with equipment, Doppler radar type equipment, being able to sense wind speeds in excess of 300 miles an hour in some tornadoes. And so the idea that we are going to see different damage results from different tornadoes, kind of an interesting image here. They even try to accentuate a different strength tornado based on looks here. But you can see the EF0s may remove a few shingles, turn over some playground equipment. EF1, now we're starting to uproot trees and do some more significant roof damage and outbuilding damage. EF2, now we're starting to get into the more significant portion of the EF scale. We got an overturned car, roofs being removed, and then EF3 is when we start to do damage to interior walls. And so you can see again the idea that between the EF4 and the EF4 effectively takes out the building, and the EF5 moves the pieces of the building and clears the foundation. And that really is the delineator between an EF4 and an EF5. Did it destroy a building, a well-constructed building, and move the materials away from where the building originally stood? And again, this becomes a greater challenge when you start to deal with locations that don't have structures. That's a good thing, to be fair, but at the same point it makes it a little difficult. So you can notice down here at the bottom there's a video here from the Rochelle EF4 tornado in 2015. I encourage you to take a look at that with the slides. So what should you do? It's prudent of us to at least take a moment to discuss safety, taking shelter. The general idea is get underground if at all possible. And if there's no ability to get underground when there's a tornado approaching, the idea is to put as many walls between you and the outside of your building. So again, a bathroom, an interior closet, definitely lowest to the ground as well is very important. So if the damage starts to occur, it's obviously going to affect the exterior walls before it affects interior walls, and you're trying to simply avoid being struck by any loose debris. There used to be a number of myths. Go to the southwest corner of your basement, for instance. Open the windows to equalize pressure. And those are not true. We're not worried about that. You shouldn't waste time trying to open windows, because the tornado, should it actually affect the building that you're in, is not going to care about the equalized pressure by opening windows. It will do the damage either way. So moving a smidge back away from tornadoes, other hazards that come, we have features known as downbursts. Thinking back to our our rain-cooled air. We can get really intense rain-cooled air that's held aloft for a period of time within a thunderstorm that makes a sudden rush in our downdraft to the surface. And so the idea of what's happening here is that this really strong wind comes down, sometimes unexpectedly. We can see some signatures on radar, but these reach the ground and then they spread out laterally in all directions. These are particularly dangerous and are actually highlighted due to a couple of unfortunate aircraft incidents back in the 1980s. And so we do have some ability to detect these types of hazards. They will produce winds sometimes exceeding 100 miles an hour and in very localized ways. The idea that, for instance, if a downburst hit Valparaiso University, it wouldn't necessarily affect even all of Valparaiso. It would be a very small event, but are notably seen with stronger thunderstorms. Derecho, we've talked already at good length about derechos, and then as I alluded to the other day, flash floods are a significant threat from storms. We actually had 2 to 3 inches of rain a couple nights ago in Chicago where there was some mild flash flooding, but it is not part of the severe storm criteria. Still, if you have flash flooding, I should encourage you to not drive through areas that are flooded out. And so how do we forecast severe thunderstorms? We typically take our assessment of models, of products, of what we refer to as nowcasting, looking at what's going on in the moment, and trying to assess, do we have the right lift, the right amount of moisture, ample instability, and then we're usually looking for a pretty strong forcing mechanism in order to get severe thunderstorms. And then, of course, the critical addition, do we have enough wind shear, that speed shear and that directional shear? We need that storm tilt to occur to keep our updraft and our downdraft separate. Otherwise, it will be more like a single cell or a multi-cell. And so for the supercell, when we can get these long-lived rotating storms, it is imperative that we have the right amount of wind shear. And so in many ways, over the past couple of decades, this is where we've grown better and better at predicting some of the supercell environments and the greater severe threats, is being able to assess that quality of wind shear better. And so looking at a schematic, what you see here on the left would be a surface image of the canonical mid-latitude cyclone set up for some severe weather. You have your cold front, your warm front, so you have your warm sector here, different air masses with a dry line feature here being assessed. Actually not 100% sure what they're trying to show, because this looks like the low-level jet actually pushing up here in some ways. You wouldn't have a dry line out here into Louisiana in this instance. But again, you got this clash of continental polar, continental tropical, and maritime tropical air. Strong winds aloft, maybe from the west. Strong winds just above the surface from the south. And so we end up with a lot of shear, a lot of lift, ample moisture from the maritime tropical air mass, and that instability which is manifest between a product of your continental tropical and maritime tropical air. And so this would be a great environment for supercell thunderstorms and tornadoes. What you can see on the right then is how things may appear at the surface and as we step up, as we go up higher and higher in the atmosphere. So again, that warm sector of the cyclone, more warm moist air coming in aloft with our low-level jet, drier air as we get higher up, but starting to turn from a southerly wind to a southwesterly wind to even a more westerly wind as we get aloft. We may have this trough feature aiding in the divergence aloft. And then even things such as jet streaks, where we can really hone in on localized areas that have, let's just say, preferable dynamics in the upper atmosphere to allow for severe weather to occur. We can really focus in on even quadrants of these jet streaks. And so it's not even to where we say, hey, this entire warm sector is going to be primed. We're going to really focus in on where the greatest threats may lie. And it may be features such as this tiny little jet streak, where we say, you know what, Oklahoma and Texas are going to expect severe weather, but we're really concerned about the area north and west of Oklahoma City. We're going to put out, for instance, a high risk of severe weather, and it's going to be based on a combination of factors, including these little jet streaks and areas of strong diffluence aloft. And so this looks a little crude. It's getting to be pretty long in the tooth. This is a map from a website, weather.unisys.com, which I will be brutally honest, I'm not even sure if I can still get products, and if so, I think they look significantly better than this nowadays. But here you can see we have some type of a boundary here draped across Nebraska down into Missouri. Low pressure kind of hanging out here in the front range of the Rockies. Again, thinking of that idea of Lee cyclogenesis, you can see southeasterly flow coming up towards this boundary. And so if we look up at 300 millibars, you can see this trough out here in the west. You see this incredible divergence of air as you come out into the plains in Kansas and Nebraska, and even up here into South Dakota, Minnesota, Iowa. And then this idea of a little bit of a jet streak as well, helping to provide additional dynamics here for some type of severe weather. Again, here we're looking at 500 millibars, maybe a little bit of difference in your wind direction between the 300 millibar level and down here at 500 millibars. And we'll look at these soundings. These soundings become very critical. And so I'll keep this simple because this is not the crux of our class here at Met 103, but you can definitely pick out southeasterly flows, strong southerly flow, turning to more of a southwesterly flow. So you get both the speed shear, 20 knots, ramping up to 50 knots. And again, this is in the morning. This is noontime, actually. I'm sorry. This is a special 18Z sounding. You can see warm, moist air here by the surface. We get an inversion. And so the idea in this setup is that we need to be able to lift this air up beyond this inversion, and then we have a lot of instability. We talked about lapse rates, and that becomes pretty critical here. Again, looking now towards the evening hours, this would be for about 7 p.m. on the same day. We can see this jet streak wrapping around our trough, some really strong winds in association with this feature, but again, that divergence is really intense out ahead of it. Still similar divergence with a low pressure over the Rockies. And so at 6 p.m. this would have actually been to where there were already some storms that were occurring. You can see red line being temperature, green line being dew point, and we get some actually really spotty wind observations, but you can at least still see that directional shear starting to occur. And so ultimately this was a day that resulted in over 100 tornadoes across the plains, really focused in that area where we were in the warm sector or right along that boundary, where we saw moisture, lift, and instability, and then we saw notable shear. So you can see a couple of concentrated regions across Kansas, not too far away from Omaha, and then another cluster as we get up into the Dakotas. All right, I promised I would keep it short. Feel free to bring any questions you have to class about this, and otherwise, if you do watch this prior to Monday, best of luck studying for the exam, and don't forget about those study sessions as you need them. Take care.